Konnichiwa, hajimemashite. I understand, I got in late too. Go easy on him. So hello, I'm Noah Gibbs, a Ruby fellow with Appfolio. I'm honored to be at RubyKaigi for the first time. Thank you very much. I'm specifically here to talk about numbers and benchmarks and how fast current Ruby is compared to Ruby 2.0. Ruby 3.3 tries to be 3 times faster for Ruby 3.0 than it was for Ruby 2.0. So that's why I'm using it for the baseline. But faster is a difficult word. Faster can mean many things. So let's talk about some kinds of faster that make sense. What is it exactly? So, my benchmark is meant to measure web framework performance. I think real-world benchmarks are a very important thing, and I think that they help a lot. So what do I mean by real-world? Well, last year, here at RubyKaigi, Matthew Godet titled his talk, "How are we going to measure 3 times?" He suggested several types of benchmarks that were missing, including the web framework, and he said that we should have some kind of a real-world Ruby on Rails benchmark that can be many different things. I decided to make use of an application called Discourse. Discourse is forum software, it is open source, it is Ruby on Rails, and better yet, it is used by many, many people. And so I thought that it was a very good example of a real-world web application framework, real-world Ruby usage, a real-world application. So, I did a lot of measuring how long it takes to serve requests and how long it takes to serve a first request. That's one of Mats's Ruby's great strengths, and I think we need to preserve it. He also talks a lot about warm-up iterations. I'll talk about what those are. I'll talk about why they're important, and I'll talk about how they matter to Mats's Ruby as well in a great deal of detail. Also, when I get nervous, I tend to talk fast. Anybody in here, feel free to yell at me, slow down. I'd be good with that. So, I haven't had a lot of good luck with the conference Wi-Fi, so I will play this video locally. When I say Discourse is forum software, some of you know exactly what I mean, some of you don't. So this is a recorded example of using Discourse, recorded on my development laptop using the seed data that I use for my benchmark. So if you wonder, when it is getting topics or making comments or doing other things that forum software does, this is an example of it doing that with the same data that you're seeing speed results for. So what would this look like if you showed it with a web browser instead of running it in a benchmark? This is what it would look like. This is what it would do. You can see that it has titles for the posts, it has topics, and then after the initial post, there are more replies afterwards. So when it's checking these things with the benchmark, that's what it's checking. So, I thought I would base my benchmark on simulating user behavior. One thing many people are curious about with a Rails app is how fast is it when many people use it? That makes sense. And I chose to do that with repeatable random requests. So, that means that I generate actions according to a random seed to send them to Discourse. I used Discourse, checked log files, and used that to determine the structure of the URLs, to determine what URLs Discourse uses, and then I wrote a script to generate those randomly from a seed. For a specific random seed number, the same actions happen in the same order, and that's important to check a complex workload many times. And of course, with a benchmark and doing statistics, you want to check the same thing many, many times. Here's an example random seed from the random number generator with the first few requests that it generates. So when I say it generates some random URLs from this, you can see the first one is a post to sessions, which is a login. The second one is a post to /posts, which creates a new post. The third one is getting a specific topic. And so the benchmark generates some seed data, the same data that you saw in the video, and then it generates requests against that. Of course, this is only a few requests. There are many, many requests in the benchmark. The other part of RealWorld for the benchmark that I thought was important was to configure it the way that many companies configure their Ruby servers, Ruby on Rails servers, but also I've done the same thing with Sinatra and with others for small startups, and this is, the load testing of course is different, but the basic setup with Puma is very similar, and so I used the Puma web app server, which uses both threads and processes. I set it up after some testing on a fairly large virtual machine, an AWS M4.2x large dedicated VM. For those of you that don't know, dedicated means that it gets its own instance. It can't have noisy neighbors, other VMs on the same machines taking load from it. The Puma setup with 10 processes and 60 threads was determined by running in a lot of different configurations and recording a lot of data. Basically, that number of threads or processes would change for a larger or a smaller virtual machine. But for this virtual machine, that's pretty good for saturating it, for fully using all the machine cores. For those of you who have done similar things, you'll find that because of Ruby's global interpreter lock, having many more threads than processes, in this case 6 to 1, is pretty common. It usually takes 4, 5, or 6 threads per process, because with the global interpreter lock, otherwise the Ruby threads will spend a lot of time waiting on that lock for each other, instead of actually executing Ruby. One major trade-off to the RealWorld benchmark that I made here is that the load test threads, the database, and Puma and the Ruby server all run on the same virtual machine. That is a significant trade-off. In a real production application, one of the things that you would do would certainly be to separate that into multiple VMs. Those of you who are familiar with AWS probably already understand why I have done that, both because of noisy neighbor problems and because one of the biggest sources of delay in using Amazon AWS for testing is network delay. And so in this case, by putting it on the same machine, I'm removing a large source of uncertainty and delay that has nothing to do with Ruby. But the flip side of that is that it's running it all on the same virtual machine, which is not a real production deployment. Anyway, that is a very quick summary of my methodology. I've run it by some Ruby experts and of course spent a lot of time testing it. I would love in the questions section later to talk about any questions you have about the methodology, any trade-offs you'd like to talk about. And in general, I'm still absolutely looking for new recommendations here. I do change little parts of what I do periodically to get a better benchmark. And if any of you have suggestions, I would love to talk to you about it. So, one more piece of background before we get into, the interesting parts, the graphs. Warmups. I said warmups. Some of you already know exactly what I mean by that and are entirely on the same page. But let me show you a graph that shows you, for those of you who don't know, warmups are additional untimed requests that you run with your server before you begin timing the requests. So if I want to time 3,000 HTTP requests with my benchmark, I might say, I'll do 1,000 warmups first. And that would be a 1,000 warmups, 3,000 iterations configuration. If you haven't done much benchmarking, you might say, why? Why would you run 1,000 untimed requests first? And the answer is that for many pieces of software, it takes them a long time to hit full speed between data caching and method caching and a number of interesting things with the memory system. Some implementations actually take a long time to get up to full speed. And this example is shown with Matz's Ruby. That's MRI, the red line. You'll notice it's very flat. They have very good startup speed. And JRuby, that's in green, which takes a little bit of time to get to full speed, but mostly it's pretty flat. And JRuby and Truffle, that's the same thing as Truffle Ruby, which you may have heard of, which is much more complicated and does a much more intricate thing. And as a result, it takes a lot longer to warm up, but it gets much faster when it's fully warmed up. That's a good example of warm-up. Just-in-time compilation systems especially, things that take your code and figure out how many times it gets run and then compile it when it's been used heavily, are especially prone to have warm-up because it may take them a number of iterations before they compile your code and before your code speeds up. So when I say warm-up iterations, that is what I mean. Additional iterations before I start timing. And one more thing. It's a real-world benchmark using Discourse. That's great. Because it's real-world software that is primarily used by real people, they don't keep full compatibility of all versions with everything. So I used an old version of Discourse to check Ruby 2.0 speed up through 2.3.4. I used Discourse 1.8, which is very recent, to check Ruby 2.3.0 and 2.4.1. And to do those tests with two different Discourse versions, we have to not just check old Ruby with old Discourse and new Ruby with new Discourse. We need there to be overlap to find out whether Discourse changed speed in the meantime. So you're going to see a bunch of graphs with two sides, an old side and a new side, with one Ruby version in common. So that's great. That's a lot of background. I would be bored listening to all of this. Thank you very much for sitting through it. What can we learn with this real-world benchmark? Well, the first thing we want to know is we're going to be serving a lot of web requests. How much faster is new Ruby than old Ruby? Obviously, that's interesting. I made it the title of the talk. Do you like graphs? I love graphs. Thank you. So each set of 5 bars, each group of bars here, is showing you the minimum time for each load thread to receive 100 fully served HTTP requests correctly, and then the 10th percentile time, and then the median, and then the 90th percentile time, and then the maximum or 100th percentile time. In other words, if you look at the top of each group of 5 bars, what you have is a kind of mini graph showing you the performance of that exact Ruby and Discourse version. I find this is a great way to look at things where the performance varies a lot. In this case, the amount of time, which you can see is in seconds, shorter is better, is the amount of time it takes one load thread to fully go through its 100 requests. 30 load threads, 3,000 requests. Each one takes 100 requests. And so there's significant variation in the times. So looking at the Discourse version 1.5 side on the left, between Ruby 2.0.0 and 2.3.4, it gets, depending on which bar you check, between 45 and 50% faster for Discourse version 1.5. That's pretty good. That is really very good. And then if you look on the right for Discourse version 1.8, between Ruby 2.3.4 and 2.4.1, it gets about 3 to 5% faster. Not bad. I mean, it was already a lot faster, so the fact that it did not get slower is very good. But Discourse gets about 20% slower. That's not about the Ruby version. That's for the application I'm using to measure. The more recent version that supports the more recent Ruby gets slower. So it's really good that we measure it. This actually shows exactly why it's important to have a Ruby version in common, in this case Ruby 2.3.4, to see where Ruby is not getting slower. Ruby is getting faster, but the thing I'm using to measure got slower. If I just checked Ruby 2.4.1, it would look like there was a huge performance regression, like it got slower. And it didn't. It actually got faster. So, quick summary for all of that. For just processing HTTP requests, Ruby 2.4.1 is just over 150% of the speed of Ruby 2.0.0. That's pretty good. It's not 300%. It's not the 300% we would love to see for Ruby 3x3, but it's very good, especially for a mature language. So, let's look at another topic with more graphs. Does Matz's Ruby need warm-up iterations? Yes, these other Ruby implementations obviously need them more, but does Matz's Ruby get anything at all from warm-up iterations? It's an interesting question, I think. Among other things, it changes how I design the benchmark, which currently uses 100 warm-up iterations. You know, is that a lot? Is that too many? Is that not enough? So, this time the groups of 5 bars mean something different. There are still groups of 5 bars, but each group of 5 bars is not a percentile here, like on the last graph. Instead, the leftmost bar is with no warm-up iterations. The one next to it is with 10 warm-up iterations, then 100, then 1,000, then 5,000 warm-up iterations. So the leftmost group there, where it says Discourse 1.5, Ruby 2.0.0, and there are 5 bars, that's how much faster, if you run the entire benchmark through each time, Ruby 2.0.0 gets for that benchmark in throughput by giving it that many warm-up iterations before you start measuring its performance. So that's interesting. You remember that the graph with Warmup showing MRI showed it very flat. It was hard to tell if it was entirely flat, and now you know it wasn't. Ruby 2.0.0 does, in fact, get faster with some Warmup iterations. So, more warmups equals better throughput. In other words, yes, warmup iterations do help Matz's Ruby, and you can see that in all 6 of these groupings, that overall those numbers move up and to the right. It gets more subtle. You know, with 20,000 warmup iterations, you don't effectively see any more gain at all. And those of you who are watching very carefully may notice that Ruby 2.2.7 and 2.3.4 actually don't seem to get faster after 1,000 warm-up iterations, although that's very subtle. That's a small enough effect that it's kind of in the noise. But the other interesting thing is that overall, for the 5,000 warm-up iterations, the slope along that top is about the same. By about the same, I mean I spent a lot of time with a calculator sitting and doing divisions. I promise you they're very close. So, the answer to that first question. 5,000 warm-up iterations increase the requests per second by about 5 to 7%. So Matz's Ruby is helped by warm-up iterations. It gains about 5%. That's not a lot, but it's not nothing. So that's interesting. And perhaps a more interesting question. We've been adding generational garbage collectors. We've been adding more complicated systems to newer Ruby. Does Ruby's current generational garbage collector need more warm-up iterations? Certainly when we add JIT, it's going to need more warm-up iterations. The other implementations need more warm-up iterations. And the answer, which you just saw, is no. The slope is the same in Ruby 2.0.0 as in Ruby 2.4.1. So the worry that if you have generational garbage collection, you'll need more warm-up iterations before it's fast, they seem to have fixed that problem completely in current Ruby. All right, so we've done a lot of checking with how long it takes to process requests in a very concurrent environment with a lot of threads, with a lot of requests. But what about the time to first request, when you're just seeing how long it is before your server is up and running and can serve one request? So again, you see Discourse version 1.5 on the left, Discourse version 1.8 on the right. And again, you see overall that the direction is moving, down and to the right. That's good. These are all in times, so smaller is better. And it's, again, the number of seconds it takes until it can successfully serve the first request. So, from Ruby 2.0 to 2.3, it gets 23% faster. From Ruby 2.3 to 2.4, it gets 10% faster. Now, you can also see there that from Discourse version 1.5 to Discourse version 1.8, it also gets about 15% faster there for Ruby 2.3.4 in the two cases. So in this case, Discourse isn't getting slower and causing us problems. Instead, it's getting faster and working even better. And in fact, it's more interesting than that. Have people here heard of BootSnap? Nod, shake heads, nothing? All right. There is a piece of software that is becoming more and more common in Ruby and Rails apps called BootSnap. It uses a combination of pre-parsing Ruby code, very similar to Koichi's Yomikomu gem, and caching things in the require path to substantially increase the speed of Rails apps. Discourse boots twice as fast with BootSnap as it boots without. And the two things that I mentioned, pre-parsing the code and parsing things in the require path, should not sound very Ruby on Rails specific to you. Many large Ruby apps have exactly those problems. And so you can probably expect that large Ruby apps of every description are going to boot a lot faster in the near future. Rails 5 is actually making BootSnap part of it. And so I think that will also help drive the change. And yet, even without that, even not using BootSnap, Discourse got 15% faster, and it's going to get another 50% faster. So, time to successfully handle a request, time that you sit before you can do your debugging, is going down. Ruby 2.4.1 is about 30% faster than 2.0.0 for the time to first request. All right. So, I've talked a little about the benchmark, and I've shown you the data that it works on. I haven't talked about how you might use this to answer your own questions. I mean, I'm just some guy. There's no reason you should trust me. I will be happier if everybody in this room says, I don't believe him, and goes home and gets all your own numbers. That would be great. Again, I've had some trouble with the conference Wi-Fi, so I'm going to bring my local video up to show this. But this is essentially using the same images that I did with Discourse installed with these specific Ruby versions. You can boot up an AWS image of your own, and you can run the benchmarks on your own and get the same kind of results that I did. All right. And sorry, the dialogue that was hard to read there was just saying that these commands are in the slideshow. I'll post the slides online and are in the README for my benchmark. All right, and if you, come on. If you look there, the command line is only as complicated as it is because I am running a script that runs a command in each of the Rubies that are installed there. This is just running a for loop with 20 iterations of the benchmark with, in this case, 3,000 work iterations, 100 warm-ups, and no times restarting the app to find out the time to first request. And then the benchmark will run, including starting Discourse a number of times and running many requests against it. And then it will create these JSON files in your directory, and you can copy them off your EC2 instance, as I show you here, or any other way that you normally move files to or from an EC2 instance. And then, of course, terminate the VM. These things get expensive. The code is available, of course. This URL is the same as it was when Mats mentioned the benchmark at RubyWorld. It's come along a little bit, but honestly the code has stayed pretty similar. I've just been running it against a lot of different Ruby configurations. Though again, I'd love for you all to look over it and tell me what I am doing wrong. That would be great. Also, I have copies of all of my JSON data from this presentation and the code that I used to make these graphs, and if that will help you in any way, please request it from me. I hope you'll make your own JSON data files by running the benchmark repeatedly, but if you wanted to look over my data and see where I've been misleading you with these graphs, I would be happy to let you do that. You can run the benchmark locally if you don't want to start an AWS instance. I understand, they're expensive. It's essentially a little Ruby script that manages a Rails app, that manages a copy of the Discourse app. You'll need to create and migrate the Discourse database. There's a seed data script that I have. Again, I showed you the seed data that it uses, and you run that script against it and then run the benchmark. There is a setup script that does it when you build an AWS image of your own, and that code is all in the repository. Or again, you can do it locally, and there are instructions for how to do it in the README file, as well as commands in this slide deck, which I'll have a link to in a moment. When you run on the command line, you saw there were a couple of things that I did in the example video. You can say -W for the number of warm-up iterations, -S for the number of time to first samples. Those are very slow. You may have noticed from the graph that it takes between 6 and 9 seconds to run one iteration of that. So understand it could be slow. Total number of request samples, that's regular iterations. You can also tell it how many load threads to use and how to configure Puma with that number of threads and processes. And so if you want to check things like how Ruby performs with high concurrency, this can be a great way to do that. And this stuff is all in the README. Future work. I'll try to cut this reasonably tight. So the blog that I give the URL for there is where I've been publishing this data little piece by little piece as I go along. So a lot of what you've seen in this presentation was from there, though not presented quite as well. As well as some other questions like, Ruby has increased in speed, is it all garbage collection? No, it isn't, but the blog post has more detail. Or things like, even how is Ruby used differently in Japan, which I expect every person in this room has something they could add to that article. But yes, I do a lot of looking into benchmarks and performance stuff on that blog, and if you are interested in this kind of thing, I hope you'll have a look. There are some new JIT branches. There are some new JIT branches that have been developed recently. Shohei's optimization branch from RubyKaigi last year is an early example of one of those. As well, Vladimir Makarov's MJIT branch and Takashi Kokubun's LLRB are both interesting attempts to use JIT to make Matsu's Ruby faster in various ways. None of those branches that I mentioned are quite mature enough to work well with this benchmark, but I very much hope that it will be possible in the future. Those branches get more stable all the time. RubyBench, rubybench.org, if you're familiar with it, is a wonderful site which runs a wide variety of benchmarks and other Ruby code on new versions as they come out. And so I'm working on a pull request to add my benchmark to that, basically so that we'll get to see this for every Ruby version. When my benchmark detects a performance regression, we'll see it. For that matter, this isn't in RubyBench yet, but it's something I very much want to do for new speculative patches to Ruby. I immediately think of the hash table patches for Ruby 2.4, which require a lot of examination. It would be wonderful if we could just submit those to RubyBench and see how they perform with RubyBench, among other things. Yeah, and of course Ruby patches, as I just mentioned. So yeah, various future work is planned on this as well. Great. So, do we have any questions? Does someone have a microphone? Yes. Oh.
Thank you for your presentation. Would you tell me which Rails version each Discourse 1.5 and 1.8 using? And if the latest version, the difference is that do you still believe it's worth to compare the Ruby 2.0 and the current or future version of Ruby? Because I was thinking it's like it's better to compare the lowest version of Ruby, which can support the same version of Discourse, or which the same version of Rails.
So the Rails versions are very similar. I believe they're 4.2.6 for version 1.5 and 4.2.7 for version 1.8. Either way, they are very close together. It was very surprising to me when I found out how similar the two Rails versions were. They are working on upgrading to Rails 5, which will make a major difference, but they haven't yet. The Discourse folks have not yet made that upgrade. And so I think this is actually currently a very fair comparison because the Rails version is so similar. 4.2.6 and 4.2.7 have very few performance differences between them. With that said, when they make a much larger jump, when they upgrade to Rails 5, that may make a large difference in how it's fair to compare them. Boot time in particular is going to be enormously different with Rails 5. And so I probably will not keep comparing against Ruby 2.0 constantly all the time, certainly not for everything, but I think it's good to get this baseline to see how this performs for future reference.
Thank you.
Thank you.
Does anyone else have any questions? 誰か質問がありますか? こちら. Let's start with him and then we'll work back. Okay. Is that Koichi?
Thank you for great work. I have several questions. So one question is, so I want to try your benchmark on my local environment. How long I need to, so how minutes I need to run your benchmark?
So there's a setup script you can run that will generally work pretty well. It will probably take you 5 or 10 minutes of work to get that working. I gave a quick summary here of what's necessary, but the short version is it's going to clone a local copy of Discourse in your current development area, you will need to run Postgres if you do not already. It needs Postgres. And then you'll need to create and migrate the database and run the seed script.
Can you prepare some container, so Docker file or something like that?
I could do that. I'm a little worried about the difference in performance for Docker files, but the AMIs...
Maybe that's the beer machine, on the beer machine, so I think it is not a problem. Using such a
so RubyBench actually runs with a bare machine, so those numbers will be available. But for running locally, yeah, the bare machine is a little bit of an odd configuration. It's true. I make the AMIs available and Packer files to build those.
Back to the question. So how long? So if I set up all of them, then so I want to run your benchmarks periodically, so daily or so if I make some patch and I want to run. So how long I need to? I need to?
Do you mean how long does the benchmark run? Like how long does one run take?
Exactly.
The checking the HTTP requests, like the warm-up numbers, is fairly quick. Running one batch of them with 3,000 iterations takes around 25 seconds plus some additional startup and teardown time. So not long.
Only a few minutes.
Yeah, only a few minutes. If you run very many iterations of the startup, the time to first iteration, those are very slow. One single measurement of that takes 7 to 8 seconds at least, and you usually want to run at least 100. And often more than 100, so that can take several hours.
Okay, so you mean so no long time. So I understand.
Yeah.
Okay, so the second question is, so talking with these committers, we can't understand why the warm-up time is useful. So do you have any idea about that warming time? So warm-up iteration is effective for the benchmark, but I'm not sure. We are not sure about that.
So if you mean why does the 5% improvement happen?
Yeah.
I'm guessing somewhat, but my guess is that it has a lot to do with the memory system warming up, with it making its first few allocations.
Not the Ruby system, but under memory system, so the memory cache or something like that.
Yeah, memory cache, also just making the iterations. The other thing is that with a Rails benchmark, it's starting with a single process and forking, and so there may be copy-on-write related things happening there as well.
I see.
But I have
so
only...
what's process size, process number or thread number on your benchmark, Warmup benchmark?
So Puma is using 10 processes and 60 threads.
I see.
The load tester uses 1 process and 30 threads.
Okay.
The load tester may actually be getting in its own way with the global interpreter lock.
So you don't have a one process, one thread measurement, no?
I have some of those measurements, but they're not the standard measurements that I use. I've focused very much on concurrency. For the garbage collection blog post that I mentioned, I actually did do single process, single thread, because it's otherwise very hard to measure with no garbage collection. Otherwise, it very quickly fills all memory and dies. But yeah, I don't usually do single process, single thread.
Okay, thank you so much.
Thank you.
Okay, we still have time for several more questions.
Hello.
All right.
Hi, very nice talk. I like how much emphasis you put into the warm-up time that it takes for the interpreter, the Ruby interpreter to warm. But since we're testing real-world applications, did you consider the time it takes for the application-level cache to warm up?
So I, in effect, measured that with Discourse. But when I say I measured that, I mean I took it into account. I don't mean I separately measured it. I think that is definitely a reasonable thing to look at. I think that's potentially interesting and important. I suspect that measuring that for Discourse specifically is of more interest to the Discourse people than the Ruby people. So yeah, I think that's potentially an interesting direction. I suspect that Sam Saffron would be more interested in seeing those results than Koichi would.
Thank you.
Could
Over time, you have many versions of operating systems and of databases and framework and so forth. And I think it becomes difficult to track down causes of performance degradation or increase? Do you have any idea to track overall performance and track down or find a root cause for the performance change over time?
So a lot of what I do to measure the performance change in the face of that, which is not quite the same as your question, is to hold the version the same when I do these things. When I say I use Discourse 1.5, I do not mean that I use Discourse 1.5 with a different Ubuntu version, for instance. I was careful to use the same Ubuntu version put together with a Packer script and an image. I can show you the JSON files I used to put them together. One of the difficult things of taking a side-by-side measurement is holding those other things constant, finding a Discourse version that runs on the same Ubuntu version as the newer one so that I can just change the Ruby version across time. But you also asked about root cause analysis. So for substantial performance regressions, for large performance regressions, the first and the easiest thing to do there is often to keep varying some of that software until you find out what causes it to slow down. And again, the important thing for that is just to be able to measure it. And again, that's just a matter of holding as much constant as possible so you can vary the one thing you care about. My method of doing that is by using Packer scripts to build the images and basically have a full JSON manifest of what's in the image. And I will often change that and then build them side by side. When I say, for instance, I use the same Ubuntu version, like I didn't use the same one I've used forever. I used the same one I was using specifically for running these numbers. And so a lot of it is I don't tend to use long ago historical numbers when they might have been used with other software. I try to get everything else the same and then vary just the parts that I'm measuring, which is one reason all of this data was run again separately. You'll find it's not exactly point for point the same as what was in my blog posts because I was measuring a slightly different thing, and so I reran it all. Which can be difficult and can take a lot of time, but I've found it to be pretty effective.
Thank you.
Okay. 左側、誰か質問がありますか? Anyone have a question on this side of the building? No? One there. All right.
Okay. Thanks for great presentation and data. I'm curious about how many times did you run the one case test, like Ruby 2.00 with MRI and use like a 10 times test? If this is one case, how many times did you run? I'm curious about
So each test case is 3,000 iterations, plus for the various warm-up based ones, whichever one has the whatever appropriate number of warm-up iterations it says it uses. In general, I tend to use with 100 warm-up iterations. But usually I will run 20 full batches, so that's 20 sets of 3,000 iterations. For the warm-up ones, I did that with no startup iterations. I try not to mix those in. So I try not to mix the time to first request measurements with the request measurements. For the time to first request measurements, I'd have to look that up. I know it took about 2 days of AWS time for all of them here, but I would have to look up the number of iterations again for startup. I don't remember.
Oh, okay. So like EC2 is not related, like it's VM and EC2 is working on actual some host. I don't know what kind of host, but is it like there is many difference between one case?
So using a dedicated instance the way I did, I found very little difference because I was using a single VM. The big sources of EC2 noise in data, in my experience, I mean, I've done some. There are people who can tell you far more. But in my experience, the big sources of noise are noisy neighbors. That is to say, Amazon assigning a different VM to your same piece of hardware that uses a lot of resources. And by using dedicated instances the way I do here, I can avoid that completely. Amazon guarantees they won't do that in return for more money. And then the other source is network traffic. And because this is run single VM, it actually has no network traffic that goes outside the single virtual machine. And so as a result, the Amazon difference in network speed doesn't affect it at all because it's not using it.
Okay, thank you.
Okay, and unfortunately that's time for this session. Everyone, could we please thank Noah again for his wonderful talk.
Thank you, all of you.